Hello, if you're joining us, we're about to get started here in a moment. Give everybody a chance to log on, clear my board. Okay, so we got Ildi. All right, I'm going to be sending out some messages to everybody else to remind them that it is today. And as always, if you know anybody else, no, I guarantee you when we do it together, it's going to be easy. Very simple way. So just sent out a text message. Let me also send it out through the other app as well. Trying to see who's going to respond here. Send out a couple more. Oh, somebody else joined, or is that one person on two devices? Yeah, it's just two. Well, if it's just you and I, Illy, I'm gonna send a couple messages out. I will keep the meeting to like about an hour. Um, and yeah, you would get credit. I'm still reaching out to. I know Lillian has a valid reason for not to be here, but still haven't heard anything from Coral um, or Danny. Let me reach out to Ruth. Send out one more email, and then we'll just go ahead and get started. Okay. So far it looks like it's you and I, which is fine. All right. Let me know in the live chat if you prefer to. Yes, they're gonna be part of the test. They're gonna be big parts of the test. Both giving you a word form of it, and then asking you to create the actual binomial or the polynomial, or they're going to give you binomials and trinomials as equations, and you're going to solve them. I guarantee when we do this together, it's not going to be too crazy. Okay, just heard from Danny. She's going to be joining us. All right. Okay, so let me know in the comments here in the live chat if you would like to join the conference call, because I know for math, it can sometimes be a little hard just to type out your responses. Um, so I'd like to know if you would want to use the conference call feature. All right, Rube's on here. Okay, good. So we got some of the squad. Okay, conference call. All right, I'll go ahead and do that now.
Please enter your PIN number. Thank you. Joining the conference now.
I am on if you guys want to join.
Bailey's here.
Okay.
Good morning.
Good morning. Okay. So let's go ahead and start off with what polynomials are. Because there's only 3 of you, I'm just going to keep it to about a half hour because we're getting down to the last couple of days and I want to honor your guys' time because there's people who were showing up in the beginning that just kind of dropped off. So as a reward to you, this will be a short thing. I'll send out some more links once we're done. So what the most important thing to understand about polynomials is that they're equations, okay? And because they're equations, just like anything else, we either have to simplify it or solve for the variable. In this case, we need to simplify it. So we need to put it as, we need to take these pieces of the equation and then write it as an actual finalized equation. And I know the area model seems intimidating. So what I'm going to do, I know everybody should have had a chance to watch the video. I'm going to put up some basic questions starting out, and then we're going to look at then doing some practice problems. Okay. If you'd like to join the conference call, let me know if you don't have the number. The number has not changed, nor has the meeting ID. Okay. So let's start off. Okay. I'm going to start off with a couple of different things because I want to make sure we all understand the different terms. All right, bear with me one moment. I'm getting a couple of messages. Okay, and who just joined?
Danny.
All right.
Hey.
Hey.
Hello.
So I'm just responding to a couple of messages here. Did you have a chance, Danny, to look at the practice problems?
Yeah, I was on Khan Academy this morning. Check that out. And at first it was intimidating, but then once I started doing the practice problems, I was like, oh, duh. And so, yeah.
Yeah, right. I think initially it does look intimidating, but it's really not anything too crazy.
Yeah, it's actually kind of easier than what we were doing.
Yeah. Okay, so let's look at a typical.
Hearing me is that in the video they were talking about working with pi and a power of 2 and stuff like that. Like I have no idea how to do any of
Pi,
that.
so pi is 3.14, and that's to find the circumference of a circle. And that's pretty much the only thing you really need to know about it. That is 3.14. You're going to see some things that come up, but as you work through it, like, um, and I know the class is about to end tomorrow, but on your own, as you work through it, you'll see that once you start working the problems, they're not as intimidating as they sound. They sound very intimidating, given the fact that they're new, but it's not actually anything out of the ordinary.
Okay.
Yeah. So, so if we look at a polynomial, I'm trying to do like a brief. Actually, you know what? Let's just go on to some practice problems because I think if everybody had a chance to watch the video, everyone understands what coefficients are and the degree. Like if it's 5x to the fourth power, everybody understands the degree of the polynomial, right?
So,
So
yeah.
this is the degree of it. These are coefficients, right? So the highest number is the degree. The coefficient is the actual, like, what power we're going to. You're not going to get too many questions like that. That's why I don't really want to spend too much time on it. But what you will get a lot of questions about is actually using either the area model or the distribution method. Um, I would say to stick with the area model um, in reference to solving these. So let's get rid of this. Okay, and this also is known as standard form. This is standard form because our highest degree is first, right? Followed by our lowest degrees, right? The coefficients go from biggest to least. So that's standard form. Not going to see too many questions on that. So let's go ahead and do a problem. You can use a distribution method if you want. I would recommend using an area model. I think it's easier than the distribution method, but it doesn't really matter overall which method you want to use. So let's start off with the area model. I'm giving it to you in the area model, and then I'm going to ask you to solve it. After that, I'm just going to give you the problems, and you can use the area model or whatever method you see fit. Make sure that's showing up right here. All right, so I'll give you a moment to look at that and then solve it, and then we'll also talk about the distribution method as well so that you have multiple ways of doing it.
I don't know how to do it, so.
Okay, what about you, Danny?
Okay, so for this one, for the first box, you're gonna do 4 times 2, which is 8x, the second power, minus x, minus 4x. Sorry.
Okay, so when this is something also, if you have kids that they're using for multiplication. When I taught fifth grade, which is the way that we teach them multiply fractions. This is how we teach them to decompose. All this is breaking down the binomial into pieces. You're decomposing it, right? Decompose means to break down, right? Like when a body decomposes. So this is the same concept, right? So we're looking at then taking the 4, isolating it out, and we're going to say 4 times 2x to the second power. Well, we know that the only thing we can really do is multiply the 4 by the base here of 2, which is going to give us 8. What are we going to do with the x squared?
The 2x squared?
Well, we did the 4 times 2. That gave us 8. What are we going to do with the x squared?
You just break it down.
Correct. Does that make sense so far, LD? What's that?
Because we're pretty much never actually solving the problem. We're just combining it to make a simpler problem.
Correct. We're simplifying it.
So did we multiply the 4 with the 2, or did we do the 2x on the power of 2? What did we do? Okay.
Does that make sense so far?
Yeah.
So what next?
We're going to multiply the x with the 4.
And what's that giving us?
Negative 4x.
When we simplify this, it all becomes 8x squared minus 4x. That's it. Questions?
I kind of like this one. It's pretty easy.
You can also use the distribution method, but I feel like the distribution method makes it more confusing. But we'll talk about that later.
So what is this method?
Area model. Did you find this easy to use? Or actually, anybody could be. Danny could be Billy. Did you find this easy to use? The area model?
Yeah.
That was no to the conference call or no to the equation. Okay. Now, let's work on another one, and then we'll talk about multiplying them. So this is now getting helping us get used to the area model. And it doesn't. And you're going to look at this. You're going to go, "Oh my God, that's so intimidating! It looks humongous. What are we going to do?" But if you follow the same concept, it doesn't really matter how big the model becomes because you're still doing the same thing. The model is just a way of you showing that you've mastered it.
Picture's really pixelated.
I'm sorry?
The picture
is
really pixelated like we can.
So it's, let me see if I can get to the bottom of the board. Okay. How about, is that better?
No. It comes and goes.
What about that?
There you go. Nope. Yep. Then don't move it.
There you go. See, we got this.
So it's going to be 10x to the second power minus 4x.
Oh, you are dangerous. Nah. Okay, you're dangerous. All right. So, Ildi, where do we start?
We're going to multiply every one of the numbers in the problem by 2.
Okay. So tell me and Danny how we're going to do it.
The 2 times 5x is going to be 10x on the second minus 2 times 2x is going to be 4x.
What kind of 4x?
2 times 3, 6.
This right here is going to be what kind of 4x?
Negative
There we
4x.
go.
And then the last one is going to be 6.
And now if we're going to rewrite this in standard form, what would it be?
It's going to be 10x out of 2 minus 4x. Is it plus 6?
Correct, because it's a positive 6. We're always adding. So anytime we see the negative sign, we keep it as a negative because it's negative, but think of it as we're always adding unless we're told otherwise, right? So here they're not, it's not a -6, so we have to know it, so we know it's going to be a +6.
So do we ever solve this? So if we don't solve this?
We do solve it, but that was that system of equations that we learned, right? Now we're just setting it up. So what you're going to get is more problems setting it up, and then you'll get other problems that will ask you to solve it. So you have both ways now. If I asked you to solve this, we talked about how to do that, solving systems of equations. So you would know how to do that. This is now setting it up. Sorry, I'm going to respond to someone. Does that make sense?
Yeah. So far, this one does. I don't know if I can solve it.
Yeah, I wouldn't worry so much about solving. Remember, in algebra, it's not necessarily so much about getting the right answer. I mean, getting an answer, as much it is about understanding the problem. Does that make sense? So
Yeah.
you're going to get a lot of problems where they're like, hey, the answer for X is 2. And then they're going to ask you to put it back in and finish the problem.
Okay.
Yeah. Want to do one more?
Sure.
Go. Sorry. And let me know. I'm going to try to put it back the same way so you guys are able to see. But let me know if it's at a weird angle and you can't tell what I'm writing. I tried in the little bit of time that we had together to give you as many of the big things in algebra within math as possible so that the time that we spent together was meaningful, maybe even inspire you to take the test altogether. I've had more students take it and then pass it and then say, oh, it was luck, or I don't know how that happened. No, you know exactly how that happened because we've been working on it. And we've only hit the things that you're going to need to pass. So you can think of this as the area of a rectangle, which is going to be length times width. Not a big thing, but if you're able to solve this, not only now do you know how to do binomial, not only do you know how to work on polynomials, but you'll also know how to multiply the length and the width to get the area of a rectangle. So we're doing multiple.
So this is going to be 7x minus 4x.
What kind of 7x?
Positive.
When it's x times x, what do we get?
X.
Okay. So when you're multiplying x's together,
1x?
what's that?
1x?
Okay, so and this would be a quick review. So x, when you're multiplying x and another x together, there's actually always a little 1 up here. Every number is always to the power of 1. So when you're multiplying, you add those ones together. So x times 7x equals 7x squared because we add these little the powers, the coefficients. We add them together. Anytime we're multiplying. Does that make sense?
Kind of, yeah.
So if you don't see anything up there, we have to know it's a 1. In fact, there's always a 1 there, even when it's just a whole number, even when it's not a letter representing an unknown number. There's always a 1 there.
So, okay. So with 7x squared would it be 49x?
Well, here it's going to be 7x squared because we have no number here. Well, we have a 1, but pretty much no number here. And then we're going to add the powers, the coefficients. When we add them together, we get 7x squared.
But eventually, when we solve that 7x squared, would that just be 49x?
I would not think about solving it. I wouldn't go that far.
Okay. All right, and then minus 4x, second one.
So x.
Or not?
Yep. What kind of x would it be? What number would I write down?
Negative.
Just -4?
Yes.
What about the x?
Negative 4x.
-4x. So if I were to rewrite this in standard form, what would I get?
7x squared minus 4x.
Did that make sense?
Yeah.
I'm gonna check the live stream, see if anybody had a question. Okay, she can see it. Farouk, did you want to join the conference call? It might make it easier if you have questions. I just put that out there. Should we do some more?
So how would the question be posed? Like if in a test, how would this be a question?
So they could give it to you. They could tell you the length of a rectangle is 4. And they'll probably tell you the width of a rectangle is X or 4. And the width is 7X minus 4. Find the area. And then you're going to set up this model and solve it that way. So that's one way you could see it. Another way you could see it is where they straight up ask you to multiply the binomials.
Can we do it that way so we know exactly how it's going to be so it looks familiar when we see the question?
Yeah. Do you feel comfortable with the area model?
I'm more comfortable than I did when we started.
Okay. Yeah, then I probably
that much time, you know.
Yeah, I won't use the distribution method then right now, just so that we don't have to worry about whether or not we have enough time to look at both and then solve it both ways. The area model is a great way to practice. The area models are a great tool to use when we're solving binomials. So I'm going to put up a sample problem, and I'll let you guys use the area model to solve it. And again, if you can't see, just let me know. So let's do x plus 6. And there's a couple of tricks with these. We may not get into the tricks today, but there's a couple little tricks you can use. So you're going to take this. Remember, the goal is not to solve it. We're not doing systems of equations right now. The goal is to simplify this.
So would it be x? Can I go?
I'm sorry?
Can I go?
Yeah, absolutely. I was just giving you guys time to work.
Okay. Would it be x squared plus 6 and x squared plus 2.
Let me set up the. Okay, so.
And I don't know what we do between the parentheses. Are we multiplying?
Yes, anytime you see two numbers between parentheses, that means we're multiplying. So you're going to take this and we need to put it in the form of an area model. So how would we do that?
I'm going to do x parentheses x plus 6.
So you can do x plus 6. We're doing an area model. And then I need to do x plus 2. So I need to have a box for the x's. I need to have a box for the 2 and a box for the 6. So we have 4 boxes, right?
So the way I did it, so it's x squared plus 6.
Did you use the area model?
I think it.
Did you have this on your paper? This model right here.
No.
I would use it. I would use that method.
Okay, I don't know.
Okay. So the first thing that we do is we have to set it up as an area model. So notice how I took the x plus 6 and I rewrote it on the side. The x represents one whole block. The 6 represents one whole block. And I know we're adding them. Does that make sense?
Yeah.
Okay. Did the same thing with the x plus 2. X plus 2, the x represents one whole row. The 2 represents one whole row. Or you can think of it as rows, columns. I'm not going to get into that. But you see how every one of them has a space that now overlaps? That is now my model. And then I do exactly what I was doing before. So from here, what would I do?
You would multiply x by x in the first square.
And what's that going to give me?
X squared.
Correct. Then what?
And do we multiply 6 by 2?
Okay. 6 by 2. What's that going to give me?
12.
Now what?
I don't know.
Well, we did x times x, which gave us x squared, right? We did 6 times 2, which gave us 12. Yep. Same thing you did to the top, you got to do to the bottom. So what's that going to give me?
Yeah, finish it. What do you mean? You do the same thing on the bottom.
So here, this might be an easier way to look at it.
Okay.
So
you gotta multiply 6 by the x.
Yeah. Yes.
Oh, okay.
Yeah. So here's an easier way. You could say x times x is x squared. X times 2x is, or x times 2 is 2x. And then you do the same thing with the 6. 6 times x is 6x. 6 times 2 is 12.
Okay.
Now what do we do?
So now what?
Yeah, exactly. Now what?
Right.
What do we do now? We need to rewrite it in standard form.
Standard form. So it would be x squared plus 6x. Then I don't know what I do with the second set of numbers. Do I multiply the second?
Yeah, no, but we got to combine them all. We got to add them all together.
So is it a plus?
Correct. We got to add them all together.
Okay, so it's plus 2x.
So what is 2x plus 6x? That way we don't have to write all of that down. What is 6x plus 2x?
8x.
There we go.
Okay, so x squared plus 8x.
Is that all the numbers from our model, or are we still missing a number?
Square plus 8x plus 12.
Correct. And that's it.
Okay. All right, I want to do another one.
All right, and I'll show you a little trick since we're down like the last 9 minutes, and I really appreciate you ladies joining us or joining me. So there's a trick you can do. When you see a binomial like this, a quick trick you can do, and again, if you don't understand the trick, it's fine. Keep using the model. This is just if you want to breeze through some of these quick questions, right? So you can say x times x is x squared. Because there's no other power, there's no other coefficient, we know it's going to be x squared, right? Then I'm going to add these together, which is give me 8, and I'm going to just bring the x down. This is just literally just memorizing. So there's no rhyme or reason. We're just memorizing. The model shows that we took everything apart and we're multiplying those parts. This is just literally memorizing steps. No rhyme, no reason. We're just memorizing steps. So if you want to have this in your bag of tricks, you can. So it would be 8, and then I'm bringing down the x. Because I added these, I also now need to multiply my 6 and 2, which would give me 12. Again, this is an algorithm. We don't really use this to teach anymore because we don't like anybody to memorize. But you guys are going to be testing, and I want to give you as many tools as I can. So you could memorize.
Will there ever be a 3?
Huh?
Will there ever be a 3 set of numbers instead of the 2? I mean, the 3 set of parentheses instead
Correct.
of 2?
Those are called trinomials, and you can use the area model to do those too.
Oh my god!
But you're killing it, Illy. You ended up doing the binomial pretty much by yourself.
Okay.
Yeah, you got this.
Thank you.
Yeah, you're welcome. You want to do another one?
Sure.
All right. So we'll finish up with this one, and then I'll send out the link again if you guys would like it. And then we'll pick up with binomials tomorrow as well. And that'll be the last day. If you guys have questions, even when I'm not your full-time teacher, I know the program is pretty much going to shut down for the summer. Feel free to reach out to me. I'll help you out with anything I can. And I know your navigators the same way. These are very uncertain times, so could be a possibility that maybe they do extend the class or things look different based off of the fact that we had to shut down and everything else. So definitely keep in touch.
That's awesome. Thank you.
Very welcome.
Okay. All right. So.
And that's x plus 1. If it doesn't show up very clearly.
Yeah, I'm ready.
Okay. How about you, Danny? You've been quiet.
Yeah, I'm good.
Okay, no worries. No, I thought you were tracking, so yeah, I was like, she's probably smoking this. Okay. All right. So let's start off with how we would set up the area model.
So I made the square just like you did before, and I wrote on the left side x plus 8. And then on top I wrote x plus 1.
Oh. And then what? Sorry. Move the head a little bit.
I divided it up into four areas. 4 squares.
All right.
Yeah.
And then what?
And then I multiplied x with x, so that's x square in the first square. And I multiplied x by 1, that's x1.
X1 or 1x?
Oh, 1x, I'm sorry. 1x,
Okay.
1x. A little dyslexia. Okay, 1x. And then I multiplied 8 with the x on the bottom. That became 8x. And then I multiplied 8 by the 1. That's 8 in the last square. No?
Correct.
Okay. And then I wrote down the problem. X squared plus I added all the x's together, so that's 9x plus 8.
The end. You got it.
Oh, thank you. All right. So if we did it with more sets of numbers, then how would we split up the square into?
Yep. You split it up with as many. Every piece of that needs its own row, and as long as you do that, you can add in as many numbers as you want. Now, there will get a point. I'm sorry?
Can we do an example?
With the trinomials. So let's say it's that with x plus 3. We'd have to do a whole nother, we'd have to add in a whole nother row to then signify x plus 3. So then x needs to coincide. It doesn't matter because when you're multiplying, it's commutative. So the order doesn't matter as long as you're multiplying every piece out. So we could add it to the bottom here. We could add it to another side because everything has to be multiplied. Although I think when it comes down to 3 numbers, you would probably want to use a distribution method, but you could use the area model. And in fact, with that, I'm going to go ahead and send you guys a link for trinomials. And then that we pick up with tomorrow with the trinomials. Looks like everybody was pretty comfortable with the binomials. We did about 6 problems with that. So I'm going to send you guys a link so you can work on the trinomials at home, and then we'll finish up with that, and we'll finish up the essay, and then tomorrow's the last day. Any last minute questions?
Nope. I think I'm good.
All right. So I'll see you ladies tomorrow.
Thank you.
You're welcome.
Yes, thank you. Have a good day.
You too.